Assalamualaikum warahmatullahi wabarakatuh. Today I will present about our group project for ordinary differential equation. We are from section 5, group 4, and our lecturer's name is Dr. Roshayati binti Yahya, alias Atan. Our group consists of 4, including me, Muhammad Hazim Shahmi bin YUSOFF, ni HAIRUL HAZRIL bin FADZIL, Shahrul Adli bin ZULFIKar HUSNI, and Muhammad FARID bin SHAMSUL KAHAR.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid bin Shahrul and my number matric is DE210095 and I will present about the introduction. So this is the circuit, which is the RLC circuit, consists of an inductor, a resistor and a capacitor. The circuit has EMF ET equal to 150 volts, a resistor of 10 ohms, an inductor of 1 Henry, and a capacitor of 1 over 1900 farad. If the initial current and initial charge on the capacitor are both zero, we need to find the charge on the capacitor at any time t. So for the breakdown, in this ordinary differential equation (ODE), we use the second order ordinary differential equation method to solve the problem in the figure 1. To help us to find the solution, we use the MATLAB software. The question wants us to find the charge, which is Qt, on the capacitor at any time. The EMF, resistor, inductor, and capacitor, which is 150 volt, 10 ohm, 1 Henry, and 1 over 1900 farad. For the circuit, we use the non-homogeneous method to solve it and replace by using the information given in the question using L d squared q over dt squared plus R dq over dt plus 1 over c q equal to et. We need to keep the initial condition that are I0 and Q0. Then we need to convert the non-homogeneous equation to homogeneous equation by let the equation equal to 0. The general solution of non-homogeneous equation is the sum of the general solution of the related homogeneous equation and a particular solution of the non-homogeneous equation, which is Q over QC plus QP. Formulation. In the figure 2.1, the circuit shows the series solution of second order ordinary differential equation. A linear second order differential equation is written as y double prime plus pxy prime plus qxy equal to fx, where the power of the second derivative y double prime is equal to 1, which makes the equation linear. For the method of solution, step 1, we substitute the given to the formula L d squared q over dt squared plus R dq over dt plus 1 over q equal to et for the non-homogeneous equation. For step 2, convert the non-homogeneous to homogeneous by let the equation equal to 0 and solve the equation to get the QC. Step 3, identify the fx. From the fx, we identify the solution for qp, which is a constant where qp equal to c. Then we need to find the qp prime and qp double prime. After that, we substitute qp, qp prime and qp double prime into the differential equation formula, which is ay double prime x plus by prime x plus cy x equal to fx. And we obtain the value of constant c by equating coefficient. And step 4, write the general solution as the formula q equal to qc plus qp. Substitute the initial condition I0 equal to 0 and Q0 equal 0. Finally, find and write the particular solution for the RLC circuit.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adli bin ZULFIKAR. My number is DE210106. So I will continue with manual calculation. So this is our group question. The circuit has EMF ET equal to 150 volt, a resistor of 10 ohm, an inductor of 1 Henry, and a capacitor of 1 over 1900 farad. If the initial current and the initial charge on the capacitor are both zero, find the charge on the capacitor at any time. So from this question, we get the value of ET, which is 150 volt, the value of resistor 10 ohm, the value of inductor 1 Henry, and the value of capacitor 1 over 109,000 farad. We also get that the initial current is equal to 0, I0 equal to 0, and the initial charge Q0 equal to 0. So the question is Qt equal to what? So I will solve this question with this differential equation. L times d squared q over dt squared plus r dq over dt plus 1 over c q equal to et. So we change the value of L, R, C and Et according to the information given in the question. So L we change it to 1, R we change it to 10, C we change it 1 over 109,000 and Et equal to 150. So we simplify this equation and then we get the d squared q over dt squared plus 10 times dq over dt plus 1900 q equal to 150. So we let this equation as number 1. So this is the second order differential equation for the RLC circuit and non-homogeneous equation. So we have used the information of ET, R, L and C. So we don't need to use it anymore, but we still need to keep the initial condition. So in this topic of non-homogeneous equation, we have to convert non-homogeneous equation to homogeneous equation. We have to let the equation equal to 0. Next, we have to solve this homogeneous equation so that we can get the YC. But in this case, we do not have the variable Y. So what we have is the variable Q. So we will get the QC. Next thing to do is to identify what is function fx. In our case, we do not have the variable x. Instead, we have the variable t. So we have to find function ft from the function f. We have to identify qp. So for the homogeneous equation, d squared q over dt squared plus 10 times dq over dt plus 1900 q equal to 0. So I will solve this homogeneous equation by changing the derivative into m. So 1900 is not derivative, so it is not supposed to have m. So after we change the derivative into m, we get the m squared plus 10m times plus 1900 equal to 0. So this equation does not have the real roots, so I use the quadratic formula to solve it. So we get the a equal to 1, b equal to 10, c equal to 1900. So by using the formula of quadratic formula, which is negative b plus minus square root b squared minus 4ac over 2a, we get the m equal to negative 10 plus minus 10 squared minus 4 times 1 times 1900 over 2 times 1. And then we simplify, we times the value and get the m equal to negative 10 plus minus negative 7,500 over 2. So we simplify the value inside the sub, so we get the value, and then we split it into 100 times 25 times 3 times negative 1. And lastly, we get the m equal to negative 10 plus minus 10 times 5 sub 3i equal to 2. The negative 1 is equivalent to I. So next we simplify again the quadratic formula. We get negative 10 plus minus 50 sub 3i over 2. And lastly, we get the value of m, which is negative 5 plus minus 25 times 3i. So we get the value of alpha, which is -5, and beta is 25 set 3. So we have the complex conjugate root, so we need to use this equation, which is QC E alpha t bracket A sin beta t plus B cos beta t. So we insert the value of alpha and beta. So we get QC equal to E negative pi t, e to the power of negative pi t, bracket A sin 25 sec 3t plus B cos 25 sec 3t. And then we find from the question we get the ft equal to 150. 150 is a constant, so the qp is also a constancy. Next we have to differentiate constant, then we get the 0 for the qp prime equal to 0 and the qp double prime equal to 0. Next we substitute the qp prime, qp double prime and qp into the equation 1, and then you get 0 plus 10 times 0 plus 1900 c equal to 150, and you get the value of c, which is 3 over 38. And we substitute the value of c into the qp, so we get the qp is 3 over 38. Then for the general solution, we use the formula Q equal to QC plus QP. So we get Q E power of negative 5t bracket A sin 25 sec 3t plus B cos 25 sec 3t plus 3 over 38. So we mark this as equation number 2. Now we have our general solution for this RLC circuit, but don't forget that we have our initial condition that not have been used yet. Next, so we have two initial condition that we have not used yet, which is I0 equal to 0 and Q0 equal to 0. For I0 equal to 0, we need to have equation I. So we use equation I equal to dq over dt. So we need to differentiate equation number 2. For the equation number 2, we need to use the product rule, which is u equal to e power of negative 5t, v equal to a sin 25 sec 3t plus b cos 25 sec 3t. du we get negative 5 e power of negative 5t, dv we get 25 sec 3a cos 25 sec 3t minus 25 sec 3b sin 25 sec 3t. So insert the value I equal to u dv plus v du. You get the I equal to e exponential e power of negative 5t bracket 25 sec 3a cos 25 sec 3t minus 25 sec 3b sin 25 sec 3t plus bracket a sin 25 sec 3 t plus b cos 25 sec 3t times negative 5 e power of 5 negative 5t. So we label this equation I as number 3. So we substitute the initial condition Q0 equal to 0 into the equation 2. So the equation 2 is Q equal to E negative 5t bracket A sin 25 sec 3t plus B cos 25 sec 3t plus 38. So we substitute Q0 equal to 0 into the equation. So we get the 0 equal to E0 bracket A times 0 plus B1 plus 3 over 38. So we get the value of B, which is negative 3 over 38. Next, we substitute the value of initial condition I0 equal to 0 into the equation 3 above. So we get 0 equal to exponential 0 bracket 25 sec 3a times 1 minus 25 sec 3b times 0 plus a times 0 plus b times 1 times negative 5 e equal to 0. But e power of 0, and then we get the simplify 0 equal to 25 sec 3a minus 5b, and then we change the value of b. We get above 0 equal to 25 sec 3a minus 5 times negative 3 over 38. So we multiply the value of negative 5 and negative 3 over 38, so we get, and we move it to the right, to the left hand side, we get the negative 15 over 38 equal to 55 sec 3a, and we get the value of a, which is negative 3 over 190 sec 3. And then we substitute a and b into the equation 2, and then we get the particular solution for this RLC circuit, which is Q equal to exponential power of negative 5t in bracket negative 3 over 190 sec 3 sine 25 sec 3t minus 3 over 38 cos 25 sec 3t close bracket plus 3 over 38. So that is our particular solution for this RLC circuit. So that's all from me. Thank you.
Okay, Assalamualaikum. My name is HAZRIL, and I will show you the demonstration of the MATLAB. First, we insert SYMSQ, then Q equal to DSolve because we want to solve the equation. Then I will just simply input the equation into this MATLAB. So my equation is d square q per dt square plus 10 dq per dt plus 1900 q equal to 150. This is the non-homogeneous. So I will input in this MATLAB. Okay, after that press enter and it will show you this, and press Q, and it will give you the answer for Q. So we want to simplify Q, and we put simplify Q. Okay, sorry, it is simplify Q like this. Press enter. So this is difficult to understand, so we just have to press pretty Q like this, and you will get the answer same as the manual. So this is the answer. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad HAZIM SYAHMI bin Muhammad YUSOFF. Matrix number DE210091. Okay, now I will present the discussion. Okay, first is the summary of the project. The circuit that we chose as a problem to solve is a RLC series circuit. To solve this problem, we utilize the second order ordinary differential equation. We use the non-homogeneous method, then we convert into homogeneous to get the QC. Okay, then we identify QP, QP prime, and QP double prime. Okay, after we get the QP, QP prime, and QP double prime, we substitute it into AY double prime X plus BY prime X plus CYX equal to Fx. And lastly, we wrote the general solution as the formula Q equal to QC plus QP. Okay. We also use MATLAB to solve this problem. Okay. To make the Q become a subject, we use the Sims Q function. Then we use Q equal to DSOLVE to locate the answer and arrange it in order. Okay, based on the project, we were able to increase our understanding of the second order ordinary differential equation. We also learned to identify the solution of the problem by completing multiple calculation and computation. And lastly, we also know how to solve electrical and electronic problem by using MATLAB. Next is the discussion of the solution. Okay, as you can see, the first picture is the solution for manual calculation, and below it is the picture of the computation method. The result from the manual calculation method was not simplified, while the result from the computation method using MATLAB was already simplified. The result between the manual calculation and the computation method using MATLAB is still the same. Okay, that's all. Thank you.